Since many of you requested that I review prime factorization, I want to go over a problem that involves both factorization of cubic sums and differences and prime factorization. So let's look at the problem. 1029yx cubed plus 24y to the power 4. So first, let's factor the variables out. Let's find the greatest common factor of y and y to the power 4. So this one is just a y, and this one is y times y times y times y 4 times. So the greatest common factor is simply just the y. So I'm going to factor the y out, which will leave me with 1029 x cubed plus 24y to the third. As you can see, now I'm starting to get some perfect cubes. Now the big part is factoring those big numbers. So let's see how we're going to prime factor 1029. I like to use the prime bugs pretty frog strategy that I came up with. So those prime frogs, they only eat prime numbers. So if the number is not prime, the bug will leave it alone. So think of two numbers with a product of 1029. So let's check for 2. Look at the last digit. It's a 9. Since this is an odd number, so 2 will not work. Let's look at the 3. Is this number divisible by 3? It is. If you want to check, you add up all the digits. So 1 plus 0 plus 2 plus 9, which is 12. And since 12 is in table 3, that means that my number is divisible by 3. So 3 is a prime number, so the frog is going to go ahead and swallow the 3 bugs. Yum, yum. $343. Again, this is, of course, it's not a prime number. So the frog will jump one more time looking for bugs. So what are the two numbers that will lead to the product of 343? 7 and 49. 7 is a prime number, so the frog is going to go ahead and eat the prime bug. Yum, yum. And then 49, it will jump again, and it will get 7. 7, good. Everything is prime, so yum, yum for all these bugs. Now, let's factor 24. 24 is a lot easier because it's a smaller number. Again, we have my other frog. It's going to jump. You can use 6 and 4. None of them is prime, so the frog is going to let them fly by. And then she jumps again. 3 and 2, both prime. So the frog will swallow these bugs. And then 2 and 2, also prime. So the frog will, of course, swallow these bugs. Now, when you look at the two frogs, or the two factor trees, if I want to use mathematical terms, now they're going to discuss what did we have in common. Well, the first frog has the 3, and the second frog has the 3, so 3 is a common factor. Looking at both trees, these are the only common factors. So 3 is my greatest common factor. So let's factor out the 3 and rewrite the expression one more time. Don't forget your y. So I'm going to have 3y. Now, since my 3 is factored out of the 1029, what's left? 7 times 7 times 7, or simply 7 to the power of 3. I also have my x cubed plus, when I factor 3 out of 24, I'm going to have 2 times 2 times 2. So it's 2 to the power of 3. And I also have my y cubed. Now I can simply rewrite the expression in the sum of cubes. So I have the 3y, parentheses, 7x, all cubed, plus 2y, all cubed. Now we have it in the cubic sum form. It's a cubed plus b cubed. Now let's apply the rule. 3y, there's nothing we can do here. It's already factored out. Let's factor the rest of the expression. So, the rule says a cubed plus b cubed. You copy the bases and ignore the powers. Always, always put the plus. Always plus. Always plus, no matter what. Very independent sign. No one controls what the sign will be. It's always a plus. This sign is the opposite of the original sign. Since this is a plus, this is a minus. If that was a minus, then that would have been a plus. Now, it's the first term squared. So, 7x squared and the second term squared, and then you multiply the first and the second term. So 7x times 2y. Now this is equal to 3y is this 3y, nothing changed. 7x plus 2y, nothing changed. Times, all I'm going to do is just simplify the expressions. So 7x squared, 7 squared is a 49. X squared minus 7 times 2 is 14. XY plus 2y squared, 2 times 2 is 4. So 4y squared. And that should be your final answer. Of course, don't forget the equal signs.